Okay, so we continue to the subtopic direct solutions to PDE. Direct solutions to PDE. Let us not forget what we just learned on the partial integration. Let's look at a set of questions. I hope you have not forgotten about the notations for P, Q, R, S, and T. P is partial Z with respect to X. Q is partial Z with respect to Y, in that order. So don't forget them. They are no variables. So solve the following. R equals 6x. B. R equals x squared EY. C. XYS equals 1. D. Partial square Z, partial X, partial Y equals 2x plus 3y. We'll go through how to solve this. Please note that R and S, you have been given their notations earlier on in partial differential equation. So notice carefully. We'll begin with the A. So answer. You have A. R equals 6x. We know that R is the same as partial Z with respect to X. R from notations. We know that R is the same as, R is partial square Z over partial N squared. Partial square Z over partial N squared. So we replace it here. Partial square Z over partial N squared is equal to 6x. Now, we want to find Z. Or better still, we can write this as partial with respect to X, partial Z with respect to X is equal to 6x. This is the same as this. You know, second derivative will give you this. Now we multiply through by this. So we multiply by the outer one. So we have, when we multiply through, we're going to have this. Then we are trying to find Z. We're trying to find Z, the red one. That is what we are trying to find. Meaning we have to remove this twice. And since this is differentiation twice, it means we have to integrate twice. So we multiply through by partial X. Then here we integrate. So we put integration here. Then we put integration here. Now this and this will cancel to get partial Z with respect to X. When you integrate 6x, since it is with respect to X, when you integrate 6x, you're going to get 6x squared over 2. The constant for partial integration is f of a different function y. Good. So this gives me partial Z with respect to X is equal to 3x squared plus f of y. Now, I start to multiply through by this. I'm trying to remove the denominator. So multiply by partial x again. So I have partial Z is equal to 3x squared, partial x plus f of y, partial x. Then we integrate. So that we have to remove this so as to get this. To remove this means integrate. We put integration here, integration here, integration here. So this and this will cancel to get Z. We're integrating with respect to X. So 3x squared would have given us 3x cubed over 3. Integrating with respect to X. There's no X here. So this one will come back. I've not done the integration. I've rather written it well. So this gives me s cubed plus, now when I integrate this, I get x. So I get x, f of y, sorry. What is the constant? After integration to put the constant. The constant for this will be a function of a different letter, y. But this time I'm not going to use f because f is there. So we're going to use g of y. And this is the answer. I'll go over the second time. Now we are asked to solve this problem. So R has been replaced by this. Now we are supposed to go and find our Z. So what you have to do is that you rewrite this as this. Then we try to remove this by multiplying through by this. So we multiply through by that to get as this. Then this is left with this. So now let's integrate to remove this. We integrate both sides. We put integral here, integral there to obtain this. This and this cancel to get this. When you integrate 6x with respect to x, you're going to get 6x squared over 2. And that reduces to 3x squared. Still, we need z. So we have to multiply through by dx again to get this. Then we want to remove this by using integration. Integration here, integration here, integration there. So that gives us this. When we integrate 3x squared with respect to x, we get this. Now because this is with respect to x, there is no x here, so this comes back. Then when you integrate the x, you get x, multiplying f of y to get this. Now the constant for integral with respect to x is a function of y. A function of y. This time I'm using g, not f, because f has been used already. So this is the answer for the first one. We will continue to the C and the D. Okay, so we move on to the C. X, Y, S is equal to 1. That is the C. So we must first of all know what our S is. We must first know. So let's make S the subject because X and Y are independent variables. S is equal to 1 over xy. So S is the same as the squared z over the x dy. That is what we learned earlier on the notations. So this is S. So that gives us 1 over x plus 1 over y. Let us write this in its simplest form. So d dx is out, then dz dy is out. This is the same as this. It's equal to 1 over x dot 1 over y. So what happened now is we want to find z. So first of all, we remove this. We multiply through by the x to get this. Now we remove this by using integration. So I put integral here. This gives me the z dy. Because it is with respect to x, this one has no x inside, so it will come back. We have 1 over y integral 1 over x dx. When we integrate 1 over x, we get ln x. So we have the z dy equals 1 over y ln x plus. When we integrate partially with respect to x, its constant is a function of a different variable y. Good. So now we also multiply through by dy so that we can go and find our z. Multiply through by dy. So we have the z is equal to 1 over y then x dy plus f of y dy. This f is small letter f. Now I integrate. This gives me z with respect to y. I'm integrating with respect to y. Ln x has no y, so it will come back. Ln x is here, 1 over y. Yes. Now, because this is not specific, this is a certain function of y, dy. If you integrate a function of y, you're also going to get another function of y. So this will give me a capital letter of y plus the constant for integrating with respect to y is a function of x. Small letter, capital letter, note them. So this one gives me ln x. When you integrate with respect to y, 1 over y, you get ln y plus f of y plus small f of x. This is the answer. Very interesting. So note it carefully. I replace these notations, the PQRST, if they appear, just replace them. Then multiply through by this, integrate, get your answer in the simplest form with the arbitrary function. The next one is multiply through by this before you integrate. Okay. To the last one, the D. The D says partial square z over partial x partial y is equal to cos 2x plus 3y. I'm assuming now you know the tricks, so we'll try and avoid shortcuts. So here I'll have d dz dy is equal to cos 2x plus 3y dx. I put integral here. I put integral here. This gives me dz with respect to dy. I'm integrating this with respect to x. How do you integrate trig? If you want to integrate trig, it's 1 over the derivative with respect to x. Since with respect to x, 1 over the derivative with respect to x, so 1 over 2 times integration of the trig there is cos, times the question, plus, since it is with respect to x, its function will be a function of y. Its function will be a function of y. So we have 1 over 2 sine 2x plus 3y plus f of y. Then we multiply through by the denominator. dz is equal to half sine 2x plus 3y dy plus f of y dy. We integrate again. We put integral here. We put integral here. We put integral here. When I integrate the dz, I'll get z. This my half is there. How do you integrate sine with respect to y? So this is the y with respect to y. So 1 over the derivative of this. So 1 over 3 times, when you integrate sine, you get minus cos, then the function 2x plus 3y plus. Here, this is a function of y. We're integrating with respect to y. If you integrate a function of y with respect to y, you get a function of y. So capital F of y plus the constant for with respect to y is small f of x or g of x. Then this gives me minus 1 over 6 cos 2x plus 3y plus capital F of y plus small f of x. And this is a beautiful answer. Very, very beautiful answer. Yes, any question? You can ask a question, or you can try the questions in the course material and get back to me in case you don't understand anything. Thank you.